Welcome back, everybody. So we've talked about the nuts and bolts, sort of the mechanics of symbolic logic. We've introduced these things we called connectives, talked about simple statements, that sort of thing, but we haven't really talked much about how to determine whether or not a given statement is true or false. For simple statements, where it's not terribly complicated, the challenge is if you have a compound statement that's got multiple simple statements built into it, sort of like what I said before with my owning a cat and a dog. In some circumstances, it's false. In other circumstances, it's true. So we want to talk about how we need to take a look at that. And the idea behind it is that we're going to have to consider all possible variations of the simple statements that go into the compound statement and consider what's going on with them as far as being true or false. It may turn out that it's not possible at all, regardless of what's going on with the simple statements, for the structure to be true. It may turn out that it's always true no matter what. Those are both rare cases. Generally, there are certain variations of true and false values for the simple statements that go into the compound statement. We'll take a look at that. I wanted to start with just kind of those base connectives that we talked about last time, and then we'll take a look at some examples of getting them a bit more involved. So, first off, we have the negation of a statement. Hopefully it makes sense because I used the word opposite to describe this an awful lot previously, but the idea here is a true statement, when you negate it, it becomes false. A false statement becomes true. That's hopefully pretty straightforward to catch on to. So that's the negation. That's the most straightforward of the bunch. Moving on to what you might call the binary connectives, where we actually have two statements going on at the same time, we talked about the conjunction of two statements, P and Q. We generally only consider a conjunction to be true if both pieces are true. So you can see from the table here, we've got on the left-hand side of that bar, we've got sort of possible variations of truth values for P and Q. We've covered all our bases there. Don't stress about committing that arrangement to memory or anything. It's always going to be given to you where you need it. So, as you can see from looking in that right-hand column there, P and Q only comes out to be true if both P and Q are true in the first place. Again, that comes back using the cat-dog example. I'm only telling you the truth if both a cat and a dog are in my house. If I only have one of them saying and, I'm not telling the truth, and I'm definitely not telling the truth if neither a cat nor a dog is sitting around my house. So the conjunction is only true if they're both true. The disjunction can be a little bit trickier to understand, sort of as a result of how we use the word or in conventional English. So for our purposes, this is what we call an inclusive or. So we say a disjunction is true if at least one piece is true. It can be both, but it has to be at least one. So you can see the setup here. If P and Q are both true, it is true. You'll sometimes hear people talk about an exclusive or that blocks that and calls it false. We don't for Math 107, so don't stress about that. Again, you can see looking down that left-hand side, if either P or Q comes out to be true, P or Q is going to be true as a result. The only time this disjunction is false is if both of the individual component statements are in fact false. So again, a little bit trickier, but hopefully it kind of makes sense. It almost looks like an opposite of what we saw in some sense of the conjunction, where the conjunction was only true in one case. A disjunction is only false in one case. You can play around with that, but it's not strictly necessary. You can kind of take these guys for granted. The last of the connectives that we saw last time is probably the trickiest of the bunch in terms of understanding the format of why the truth table is laid out like it is. So if you struggle with it, it's okay. You're in good company. A lot of students who've done really well in this course end up having to wrap their heads around why this particular setup looks the way it does for a conditional. So again, remember, P implies Q. If P, then Q, however you want to say it. Like the disjunction, it's only false in one circumstance. And that's often the part that ends up throwing people off. So you'll notice it also makes a difference here in terms of the order of these things. It hasn't mattered yet how you have things arranged, but we've talked before about the order of statements inside a conditional is important. That follow the if thing. So I find it is probably easiest for students to get their heads around this if you work from a particular example. So I'm going to give you, a sample conditional statement in English, and then we'll talk through why it ends up looking this way. So consider this conditional. If you give me $5, I'll buy you a sandwich. So I usually couch this with traditional students like the roommate is going to Subway. So, your spouse or, a roommate still works, what have you. Somebody has offered to get you a sandwich if you give them some money. Now, in the first case, if you give them money and then they bring back a sandwich, that's P and Q both being true. Nobody generally argues with that, conditional then being a true statement. The person you gave the money to has told you the truth. If in that second case, where P is true and Q is false, if you gave them money and they come back without a sandwich for you, you've got a pretty good case for calling them a liar, right? So true implies false works out to be false. Okay? Those two, generally, folks are okay with. It's the bottom two that end up becoming problematic. I've had very strong students end up arguing with me about this for an extended period of time. So I get it if you have to, wrestle with it a bit. So coming back to the money and the sandwich. Suppose that you didn't give the person money. You weren't hungry or you were short on cash, whatever. You don't give them money. And they still bring you a sandwich anyway. How justified are you in calling that person a liar? Yeah, not much, right? So that's kind of the rationale here. You're going to have to give them the benefit of the doubt. If they brought you the sandwich without any money, then, they probably would have done it if you'd spotted them the cash in the first place, right? So that's why false implies true works out to be a true statement. Lastly, again, it's kind of a benefit of the doubt thing. If you say, no, I'm good, don't get me a sandwich, and they shrug, they go get their own sandwich, come back into the room afterwards and start eating, then if you went running and screaming that they're a liar, you're going to seem a little strange. You didn't offer, as you say, you didn't give them the money, they didn't get you a sandwich. Why are you complaining? So that's sort of the structure that I find built into these conditional statements that I think is useful for students to play around with. Again, these are kind of baseline things. You'll find a handout inside Moodle that actually has all of these listed in a single PDF file. It's also going to have one other truth table in there. So don't stress too heavily about that guy yet. He's a section away, but I didn't feel like making a second handout just for that one extra truth table. So these are the basics. If you've got something more sophisticated than just two simple statements into single connective, it starts getting a little more involved. So I've got a few kind of baseline steps here. You've seen when we're working with these things so far, I've had that sort of left chunk of the table so far with what the possible permutations of truth values for whatever simple statements are going on in there. Again, that format is pretty straightforward. You don't need to commit it to memory or anything. The big thing that I find where students end up having a problem with this is if they try to do too much at once. That's why I've got this second bullet point here that says don't skip steps. Don't try to handle negating a statement and a disjunction and then putting it into a conditional with something else all at the same time. I'm going to start, the next video is going to have some examples of this process in action. So don't stress that this is the sum total of what you're getting on this. But the big idea here is if you play your cards right, you're never going to need to look at more than a couple of columns of what you've already done or what's given to you in order to work out what's going on with the truth table. So look for the next video where I give you some examples of this stuff in action.